Hello, students, and welcome to another screencast with Mr. Swan. What I have for you today is we're going to start our new unit, which is Unit 10, which is Geologic History. And so for today, like normal, might as well start it off with a preview assignment. This will actually be your last preview assignment that you will ever do for me. Fun. And then we'll get right on moving right on to that. Our picture of the day. So we have underwater vehicle spots many more hydrothermal vents. Many more hydrothermal vents have been discovered by an underwater robot. The field of hydrothermal vents stretches along the ocean floor on the Juan de Fuca Ridge to the northwest of the coastal Washington state, in an area known as the Endeavor segment. If you remember, the Juan de Fuca Ridge is very, very similar because it's located right next to the Juan de Fuca Plate, something that we've talked about a few months ago. These towers emit superheated liquid warmed by magma deep inside of the earth. So a picture on the bottom right actually shows one of those hydrothermal vents actually emitting that liquid actually up into the ocean. It is theorized that life on Earth began with these vents because they were underwater, warm, and nutrient-rich places. Back in early life time, the air and the atmosphere above the ocean was pretty much inhospitable to life. A whole bunch of gases up there that if you were to breathe them, you wouldn't really live too long. So it's kind of been thought that life has begun down in the ocean and probably near one of those actual vents because it keeps it warm and it kind of has like some nutrients that they would actually use. Continuing on, these deep sea chimneys form around hydrothermal vents that build up minerals that flow to the surface in heated liquids, sometimes as hot as 750 degrees Fahrenheit. So when I said that they're hot and it's warm, it really is quite hot and it is quite warm. As hot liquid meets cold seawater, minerals precipitate and settle around the vent, collecting to form towers that can reach impressive heights. Something that this article didn't really go into too much, but I figured I'd bring up is that once one of these vents form, and they get taller and taller and they get bigger and bigger over time, is that whole ecosystems actually will form on these vents, because that's like a nice little hotspot for life actually to continue even today. When those chimneys are actually forming, what can happen sometimes is that they get bigger, they get bigger, they get bigger, and then sometimes more minerals are precipitating. They can kind of seal off, and once they seal off, then there's no more liquid going through those vents, and then that liquid that's getting pushed up from the expansion of heat from the magma from the interior of the Earth will actually move to another one or another opening somewhere like in the ocean floor, and then a new vent will actually occur. Now, those ecosystems I was talking about on those vents go away, and they never really come back. And I figured you might like to see some pictures of that. So this is kind of like what one ecosystem would look like on one of those hydrothermal vents, and I'll zoom in for you. You can kind of see like the different colors. That kind of shows that different things are actually living there. Once those vents seal off, then it looks kind of like this. This is will actually be one that has like a dead ecosystem on it. Everything once the vents shut down, nothing really can survive there. So it just kind of goes back to the environment, which was really on the ocean floor, which is really dark and really cold, and pretty much the life there actually just gets extinguished. So that's what happens to these vents. That's the life cycle in theory of a hydrothermal vent. How do they find these? So that's what the picture is in the bottom left. Research on the Endeavor vents began in the 1980s. So we've known about these for a long time. Scientists had previously identified 47 of them in about 5 major vent fields. Recent expeditions using the autonomous underwater vehicle operated by the Monterey Bay Aquarium Research Institute revealed more than 500 in a zone about 9 miles long and 1 mile wide. So if you take a look at my picture of the Juan de Fuca Ridge over here, it's a really big ridge. There's probably way more than we actually ever realized. And to find them before, you actually had to send down like a submersible, and they would look around kind of like with a flashlight and go ahead and try to find these. Now what they're using is LiDAR, which is a nice picture of this is this part. And these are just pictures I just typed in LiDAR scans. And what LiDAR is a very, very accurate way of sending light out. And it hits and it gets picked back up. And it shows you the distance that light went out. And so if you use that, you can actually scan objects. And you can actually see the differences in height that they would actually go. It really works in any dimension. So these are actually pictures of, like this one looks like a kind of like a cathedral. And that you have like maybe like some chandeliers kind of going on from the ceiling. You can see these pillars, and the nice part is that software and LiDAR has gotten really, really good over the past few years, that they're able to keep those points of light in essence through software suspended in like 3D. And so if you move your scan around, you can actually get not only just the whole 3D scan of it, but it holds its position. So what that means is that you can actually get like all this like kind of architecture just from those LiDAR scans. This stuff is the same thing that was used when we did the picture of the day showing like these ancient cultured structures like in the jungle, and they use the LiDAR scan going like on over the jungle, and they're eventually able to pick up like little bits of like kind of stone outlines, and they're like, oh, this must be in a settlement here. And they've been using that greatly down in South America, and that's what they're kind of starting to figure out. Is like, oh, these civilizations that we talked about, like the Mayans and the Aztecs, that were actually way bigger than we actually even realized, because we're finding more and more settlements of people where they actually used to live. Now everything is kind of mostly gone, just like the foundations of their buildings. And so this stuff is, you're going to see this more and more. They are probably, I think it's actually been confirmed now, they're going to start putting this into phones. And so you can actually take your phone, will have like a little LiDAR scanner in there, and it will help the augmented reality like apps. And so you'll be able to hold it up to like your room. This is me just predicting the future, right? Hold up the room and kind of like get a like, nice kind of scan of like your room, and then you could go to like Amazon or something like that and pick out like different furniture, and like you can try to drop in your room and take a look to see like how it would look. That will be like the future of shopping one day. It should work eventually with clothing too, and with like a whole bunch of different applications. So it's just kind of some new tools that are going to be becoming widely available in the future. And see what people are doing this. Now, those LiDAR scanners that are going to be in your phone are not nearly as good as the one that they're using for this. But, you know, what you get is kind of what you get. So a nice kind of way to take a look at it. Since we are talking about geologic history and the beginnings of life, this is this picture of the day fit pretty well. And then my assignment for you today is to do the Unit 10 preview assignment, which is this one. It's kind of very similar to the ones that you usually would have. My only thing I ask is that can you please answer the questions in different colors or use bold your font. It makes it a lot easier for me to read, to see where you actually began typing. And so finish that up. Shouldn't take too long, I don't think. Kind of like the normal time for a preview sheet. Also, go ahead and read through the note packet. That actually begins right here. Not this week, but the following Monday is when we'll begin working our way through the geologic history unit. And we'll start off with this. So we're kind of working our way through normal. On Wednesday, your next lesson, that will be the Ask Astronomer. So make sure you show up between 10:15 and 11 a.m. And that will be your whole assignment. So you kind of like listen to what she has to say, see like what some questions that people have asked and some answers. And then you'll just get a grade for how you, for showing up, for how you participate, things like that. And then that will actually kind of finish us up for the week. But that's your outline. Besides that, I hope you have a good day. Feel free to take an interesting kind of look through the geologic history unit as a fun one. And then finish the preview sheet and be all set. And then I will see you for sure on Wednesday. On Tuesday, I will do office hours again, just like I have been doing normally. And that's about it. So besides that, hope you have a good day and hope you're having a happy May. See you later.